Okay, 5th grade boys and girls, this is Mrs. Salyer back, and we are here for the discussion and the chance to analyze the work that we did in Task 8 on fraction multiplication. So our problem that we were looking at is 4/5 times 1/12. Remember that one factor in a multiplication problem tells you the number of groups, and one tells you the number of items in the group. Or one factor can tell you the number of rows or groups and the items in the row, or the number of columns, groups, and the items in the columns. So what are our factors here? We have 4/5 and we have 1/2. So what does this mean? I like to tell students that when we're multiplying fractions, we can think of the multiplication symbol as saying of. So we're trying to find what is 4/5 of 1/2. Now, Mandy says that you can find the answer by simply multiplying the numerators and multiplying the denominators. And if we do that, 4 times 1 is 4, and 5 times 2 is 10. We get 4/10. So Tamara says that there are 4 pieces in 4/5, and the answer is half of them, which is 2/5. So let's first look at what Mandy did. And you were asked to draw a model of what Mandy did. This is what you've been working on in class. So I'm not a great artist, but I'm going to try to make my model to show 4/5 of 1/2. Since I'm working in fifths, I'm going to come down 1, 2, 3, 4, 5. And I'm going to look at putting it into halves. Now I'm going to take my jumbo crayon, which I love, and I'm going to represent the 1/2 by coloring it in yellow. So here is my 1/2. Now what I'm tasked with doing is finding out what 4/5 of that is. So this is 1/2. And this is 1/2 because we're always talking about the whole in relation to the problem. So now I'm going to come over here and I'm going to draw my 4/5. There's 1/5. There's 2/5. There's 3/5. 4/5, and then 5/5 for the whole. But remember, I only want to know what 4/5 would be. So I'm going to color in with my giant jumbo blue crayon 4 of those fifths. Now the fifths go all the way across, so you do have to color in all the way across. And I've colored in 1/5, 2/5, 3/5, and 4/5. But I'm only interested in knowing what 4/5 of the 1/2 is. So I'm looking at what has turned green. That's the double coloring. And I have 1, 2, 3, 4 colored in. But now I need to ask how many partitions are in the whole. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So is Mandy correct in saying that 4/5 of 1/2 is 4/10? And does our model prove that she is correct? Okay. Now let's talk about what Tamara did. Tamara said that she was just thinking about having 4/5. And I told you I wasn't a great artist. If so, all of these partitions would be exactly the same. And they're not, but just pretend. And she says if she thinks about having 4 of these partitions, that would be 4/5. So what I'm doing right now is I'm coloring in 4/5. And now I'm going to think about looking at half of those 4/5. So there would be 2 there and 2 there. And half of them then would be this part right here, which as we look at the fifths, we can see that's 2 of the fifths. Okay? So what she did was draw 4 fifths and then took half of the entire 4 fifths to get 2 fifths. So now my question to you is, which diagram is correct? Can they both be accurate? How can 4/10 be equivalent to 2 fifths? If you remember back when we talked about reducing fractions, which some people call putting fractions in lowest terms, which some people call simplifying fractions, we can realize that we can divide both of these numbers by 2 to put it in lowest terms and get 2 fifths. So Mandy and Tamara both arrived at the same answer, but their thinking differed a little bit with their models. So what do you notice about the size of the product compared to the factors? Is 2 fifths less than 4 fifths? It is. Remember, when we're finding 1/2 of 4 fifths, we are finding a part of a part, which means that your answer has got to be less than 4 fifths because you're just finding a part of it. If you were finding the same thing and multiplying it by 1, your answer would be 4 fifths. If you were multiplying it by a number greater than 1, it would be greater than 4 fifths. But since you're multiplying it by a portion of a portion, then your answer has to be less than 4 fifths. So we also gave you a challenge. And the challenge was to think, will Mandy's algorithm work for mixed numbers? Why or why not? So let's look at the example. 1 3/4 times 2/3. Okay. So what Mandy may have done is she may have said, well, 3 times 2 is 6, and 4 times 3 is 12, and I'm just going to put this 1 over here, and my answer is 1 6/12. How many of you think that that worked and that applied? Some of you did, okay? But remember, when we're working with fractions and we have whole numbers, we have to turn that whole number into an equivalent fraction. So if I had 1 whole and I'm thinking about fourths, that 1 whole would really be 4/4. And then I have 3/4 with it, which gives me a combined total of 7/4. That's how many fourths that I have right there. So what I'm going to have to do is multiply that 7/4 by 2/3. Now Mandy said you go 7 times 2 is 14, and 4 times 3 is 12. This is an improper fraction. We spent quite a bit of time on it when we had our other fraction unit. And you know, you can think about 12 will go into 14 how many times? 1, because 1 times 12 is 12. How many are left over? 13, 14. 2 are left over, and the denominator stays the same. Is this the same answer as this one? No, it isn't. So you can't just multiply the fraction parts. When you're working with mixed numbers, you have to make sure that you turn your mixed number into a fraction in order for the problem to be able to be solved. Now, we thought about 1 being 4/4, and we added it to the 3/4. But we also learned how to take a mixed number and turn it into an improper fraction. I taught my boys and girls to make it mad. To make it mad means that you multiply, then you add, and the denominator stays the same. So if you're going to make it mad, you're going to go this way and multiply and say 1 times 4 is 4. Then you're going to add, and 4 plus 3 is 7, and then the denominator stays the same. So that's another method that you can use when working with mixed numbers to make sure that you have a fractional amount and that you have taken care of turning the whole number into a fraction equivalent. One way to do it is what we did right here. Or we could use the MAD method and turn the mixed number into an improper fraction, but we still get the same improper fraction, 7/4. So once you've taken care of that, then yes, we can follow Mandy's algorithm of just multiplying the numerators, multiplying the denominators, getting 14/12, which is an improper fraction, converting it into a mixed number. Now, would this be my final answer? Think about that for a moment. Can I reduce this number? Some teachers will call it reducing. Some teachers will call it putting it in lowest terms. Some teachers will call it simplifying, but all three of those terms mean the same thing. So you need to think, is there any number that will go into both 2 and 12? Well, yes, those are both even numbers, so 2 will go into both of them. Which means that my final answer is going to be 1 and 1/6 for the mixed number problem. So hopefully this task got your brain to thinking a little bit. It got you to thinking about different models that you could make to prove the answer, and you discovered that both Mandy and Tamara were correct, although their models were different. Their thinking both led them to a solution path to find the correct answer. So thank you so much for working so hard on task number 8.